Welcome, everybody. My name is Dan Weeks. I'm one of the co-creators of Apache Iceberg way back in the day at Netflix with Ryan Blue. And I'm very excited to welcome everybody to the October edition of the Bay Area Meetup. Just to kick things off, I'm going to do kind of a high-level, broad brush stroke of some of the things that have been going on in the community, just to kind of bring up to speed anyone who doesn't participate regularly or attend any of the syncs or subscribe to the dev list. But we'll go through a little bit of what's been going on in the community and where we're headed. First thing I want to do is thank the sponsors. As it was already mentioned, a lot of people contributed to this event, and the Apache Foundation has actually got a long history of supporting vendors and their contributions to open source projects. They recognize that a lot of us are funded by companies to produce these projects and build these open source communities. So thank you very much to all of the sponsors that made this possible. The next thing I want to talk about is just the activity that's been going on in the community. We actually have meetups that are happening worldwide. There have been a few of them here in the Bay Area, definitely a central tech hub, but we also have them up in Seattle. I think there's one coming up in a few weeks. We've had a few over in Europe. I believe there was one back at the beginning of the year, the end of last year in Asia. So this community is expanding very rapidly. There are a lot of people involved. But there are more ways to get in touch rather than just face-to-face, because we regularly have community syncs. These are all managed through a dev calendar that is on the Apache Iceberg website. So if you ever want to get involved with the discussions that are going on, they're all available. They're open. Anybody can join. So you can join to participate or just listen to understand what's happening in the community anytime. There are a number of these that are regularly scheduled, but we also have topical discussions that we schedule as one-offs to make progress in certain areas, or because we have very detailed things that we're going to go through. All of those are great ways to participate and learn. The next thing that I would mention is that we have a dev list. This is a place where people post proposals. A lot of discussion happens on there. All of the official Apache work happens there. So if there are votes, if there are things that are changing, if you want to subscribe, you'll get updates to those. Slack is a great place to just interact with the community, ask questions, discuss, get quick answers. I think we have over 8,500 people in the general channel on Slack, so that community is growing incredibly rapidly. And then the last thing is just the repositories, making changes, proposed changes, PRs, issues. We love to see all of that content. Please engage with the community. The next thing is the community is actually broader than just the Iceberg community. There are a lot of OSS projects that really make this lakehouse architecture, working with these technologies, making Iceberg successful. We've been working very closely with the Parquet community on a lot of the physical representations of how we store this data, Spark on a lot of the reference implementations. Arrow is supporting a lot of the different languages that read data off of disk and into Rust or Python. It's backing a lot of those. Delta Lake we're collaborating on very closely with for future updates to the format and kind of sharing a lot of the knowledge about the different challenges that we face. And then I grabbed a couple more logos to fill out the slide, but this is obviously not the extent of it. There are dozens of open source projects that are all integrating, participating, and interacting with Apache Iceberg. So what I'd like to do at this point is take just a little bit of a step back and talk about V3 updates and where we are in the community. So V3 represents the specification of the table format that was voted on just a few months ago, and it introduced a number of changes and improvements. And we've been working through the actual implementations of those, so I'm going to touch on just a couple of them. It's not expansive, but these are kind of the key ones that I think people are very interested in, and talk a little bit about where we are. So the first one is deletion vectors. So we had positional deletes in the V2 table format. Deletion vectors are an improvement over that, in that our on-disk representation and in-memory representation are the same. It allows for addressing one of the biggest challenges that we had in V2, which is that maintenance was a problem, and this requires continuous maintenance, which means that your tables will stay healthier as you introduce positional deletes. Variant type is one that's really interesting, and I think a lot of people should look at. It's introduced with Spark 4 with integration in the library, but variant is kind of a representation for semi-structured or unstructured data. It's a nice replacement for JSON. So all of those data engineers out there that use JSON, and we told them stop using it, use like schemas and use schema evolution. I always ended up using JSON anyway. This is a much better way to do it. You can have more compact representation, and then shredding allows for incredible performance improvements on scans as long as you have shredded data. And then the last piece is road tracking. There's a lot of future improvements that I think are targeted, but this underpins many of those, road level deconfliction, improved change data tracking. So many of these features were introduced and are starting to become available. The 1.10 release, which was just released a week or two ago, has kind of the basic implementations of all of these that are available to be used in Spark. So feel free to go try them out. But there is still work that needs to be done in V3. And the areas that I would say is one, with variant, we don't have shredding by default. So we can support reading shredded values, but by default, we need to do some work in order to make sure that we're producing that for optimal performance. Geotype integration. Geotype was another feature that was introduced, and we have the specification for that. Work has been done in the Parquet community, but there's still some kind of tying together and working with Spark and other engines in order to support that natively. There's multi-language support. So this is bringing the other Python, Rust, Go, C++ implementations up to spec with where the Java implementation is. They're all making progress, but those are really great places to contribute to because there's a reference implementation you can look at, and there's a lot of opportunity to make code contributions. Engine integration is another one. We've got all these great features, but now we want everybody to be able to use them. It really improves interoperability. So if you have an engine that knows how to speak V3, chances are you're going to be able to use that in a lot of other places once we get all of that integration tied together. And the last piece that nobody likes doing is documentation. So getting better docs out there about these features, how to use them, how to configure and set things up. Even documenting use cases, writing blogs, anything that helps foster adoption of the V3 specification. Now I'm going to go ahead and move on to some of the proposals and ongoing work in the community. While V3 is not, completely done, we are looking forward, and V4 encapsulates a lot of changes to address some fundamental limitations that we've been living with in Iceberg for a very long time. So a few of these can be encapsulated in these proposals that are out there. There are other ones that contribute to these or are kind of side proposals related to it, but we'll talk about these just briefly, and I think later there's a couple deep dive sessions that go into more detail on these specific topics. So the first one is just content metadata. So Iceberg is very much like a tree structure of metadata, and in V3, V2, and before, we've had a structure that is, a two-level tree where each one of those representations is slightly different for different purposes. You do filtering at different levels. But what we found is that there are problems with that representation. One, from how we produce it, which is the write amplification. If you want to write one new record, you have to add that record, you have to add manifest files, you have to add manifest lists, and you have to produce JSON. That's a lot of amplification. And many of the upcoming use cases that people have for streaming and fast writes, this is really not conducive to that. So in V4, what we're proposing is a new structure for metadata, and it encapsulates, being able to reference things differently within the tree, a more compact representation, and being able to make updates with as little as one file change. So that will really foster being able to make those fast commits and do streaming operations faster. It also helps with scan planning because we've got better statistics throughout the metadata tree. They can be used at any level. So there's a lot of improvements that we think are going to advantage many different workloads moving forward. The next one is column statistics. So the representation that we've been using previously was fine for a while, but it's shown its age in that it limits some of the ways that we can evolve types within schema evolution. So we lose a little bit of fidelity with the representation that we have in V3 and V2. And by changing this a little bit, pivoting how we store a struct, we get the advantage of both being able to have expanded type widening, but we also get improved scan performance because the way we would represent this, you can project just the statistics you care about for the columns that are used in your filter conditions. This will have a huge improvement over many of the metadata operations that we do today. We've seen from many companies like Apple that memory pressure with the size of the statistics, especially for really wide tables, can be a major bottleneck. And so this will definitely help address those. The last thing is relative paths. So since the beginning, Iceberg has always used absolute paths, and this was born of the idea that we really want to have a strong integrity of the data set. We don't want external factors like moving things around to change what represents the data. but we've also found that that is quite limiting in some scenarios. For example, being able to just copy a data set from on-prem into the cloud and then just having it work. Right now, you actually need to rewrite all of those metadata references. And over time, we've added more metadata references like delete file references and other things. So there's a lot of metadata work that needs to happen in order to just move a table. There are other more enterprise use cases that are coming up, like disaster recovery and like seamless replication. So if you want to do multi-regional replication or have copies in different continents for locality, all of these are really difficult to achieve if you have absolute paths because it requires lots of orchestration and metadata rewrite. It's very difficult to keep like the history of the tables in sync. There are mechanisms to do it, but we'd rather relieve that burden by updating to have a way to represent relative paths, but not lose the capabilities and functionality that we had of being able to address files wherever they happen to be. So that's the other major thing that's going on. In these discussions, there are many open topics. One of them, as an example, is just we have a construct that everybody is largely familiar with, which is partitioning. It goes all the way back to like HDFS, file systems, directories, how do you lay out your data? And that has permeated through table formats to this day. We made some initial choices to like abstract that a little bit with partition transforms in Iceberg's versions 1 through 3. But now we're looking at, are there better ways to track that metadata? Should we do that in statistics to allow for more fine-grained partitioning that isn't necessarily statically structured? Do we want to have separate representations for stats and metadata? Do we want to introduce expressions that give us more flexibility and how we represent partitioning? So there's a lot of discussion that's going on there, and there are docs that kind of lay out some of these challenges. The next one is around scaling deletes. How do we want to represent deletion vectors? So when you want to delete something very quickly, we've got a couple different mechanisms in Iceberg, but the one that a lot of people use is DV. So you're scanning your data, finding where the record is, and then overlaying a delete on top of that, or a delete and an update. And the way that we represent this and was introduced in V3 is DVs against data files, just pointing out, hey, which position within that data file do we not want to include in a scan? But we're also up-leveling that because we want better management of the manifest. Like, how do we manipulate that content metadata tree? So we want to be able to delete references from that content metadata tree similarly to how we do that in data files. So there's a number of different ways that we can structure this. You can put them in line, you can put them out of line. So there's debate going on about what is the best representation, how do we achieve kind of the goals of scalability, high scan performance, and being able to do focused deletes against the data and come up with a solution that kind of strikes a balance across all of those. The next thing is a lot of the proposals that have been coming out, we'll talk about one or two in the next section too, is they kind of rely on more complicated sharing of information between execution engines. And this is where we're thinking about things like expressions and different kinds of statistics. How do we track these things? Is it something that we want a common language for? Do we want them to be opaque? So these are open discussions, and you'll see them if you look through some of the proposals interleaved as like, oh, well, maybe we can rely on expressions here. Maybe there's something that we can track in statistics to deal with those scenarios. And the last piece is like, as we do all this restructuring, a major capability that people are looking for with their data sets is change data feed, understanding how data is changing, either to source a table as like a stream that you can consume from a stream engine, or you're doing some sort of replication replay kind of logic. There are lots of scenarios that you want to know how your data set has evolved from commit to commit. We want to make sure that as we're designing this, that we don't make this incredibly complicated or expensive to reproduce. So change data detection, change data feed, those things are things that we still need to kind of do a deep dive in and understand how all of that behaves. The next category of things that I want to touch on is the catalog space. So we've spent most of our time so far talking about the actual table specification, but the catalog is an emerging area where I think everybody sees that there's a tremendous amount of value. Catalogs represent how do we identify data sets, how do we load them, the management, the background activity against them. And importantly, how do we secure these data sets? The REST spec is something that came up a few years ago in Iceberg and has gained a lot of adoption for providing a standard interface to addressing, loading, and updating tables. It does a lot of other things as well. We've got representations for views. There are like scan plan APIs that are being worked on. We'll touch on a couple of these because these are kind of the active discussions that are going on today. So the first one is scan plan APIs. And the very original intent behind this was to help reduce the amount of complexity that clients have to implement in order to read or consume a table from the catalog. So there's a lot of complexity in navigating that content metadata tree, filtering out what you don't need, and figuring out which files do I need to read and what kind of filters do I need to apply as I read those files. So the scan plan APIs kind of push a lot of that logic back to the catalog. And the initial intent was just kind of reduce complexity, help onboard, new engines, new clients that don't have all of this capability quickly. But we realized that this actually provides a great abstraction for lots of other things, including like legacy formats like Parquet tables or even Hive tables if you're doing some sort of migration. You've got different representations that can be addressed in many ways in the scan plan APIs. And then the other piece of this is just being able to apply things like fine-grained access control. You can kind of manage what data is accessible. You can rewrite data. There are a lot of approaches that leverage the scan plan API. And so I think there's a lot of interest and investment in trying to get those implementations, even though we have the specification already defined out there. The next category is kind of a mishmash of things that are not exactly REST, but are somewhat related. UDFs, materialized views, things where we want to share some sort of business logic. We want to share some sort of materialized representation of data. These are really powerful features. And I think that as we get to being able to define semantic layers or other things, you want to be able to have common representations of like, how do you perform some sort of calculation that you share across your organization? I mean, the good example would be something as simple as, how do I calculate my fiscal year? Like some companies, they're offset from like every other calendar in the world, and you want to have a UDF that you can share across all of your analysts and say like, this is how you determine the windows for our financial calendar. Everybody produce the same results. So those kind of things are use cases where we want to, express that business logic and push it down to the engines from the catalog, put a lot of that functionality behind those interfaces and standardize it. And the last thing that I would mention is I said that like a lot of people are adopting the Iceberg catalog interface. We're seeing it across many of the cloud providers, many of the catalog implementations that are out and available, both open source and proprietary or vendor implementations. But this means that we are getting to a point where this is a operational system that people need to rely on. We need strong guarantees about correctness, behaviors. And so what we're making sure is that we have the capabilities within the protocol to do things like, hey, if there was a network hiccup, I don't lose hours worth of processing just to commit that operation. So like item potencies and keys help address challenges like that, where if you had some sort of, gateway interrupt, like a client can still retry that operation. The catalog can deterministically tell you, hey, I applied that commit, I did receive it, you're okay, or no, I'm going to apply it because I didn't actually receive it. There are a number of challenges in just like the error handling cases and other things that have caused a lot of pain for people who are running this at scale. And as they like ramp up the number of commits and the performance against the catalog, you're going to need functionality like this in order to make it a robust implementation. And the next piece is like this freshness aware loading. Mechanisms within the protocol so you can tell whether or not you need to reload data from the catalog. This is really helpful for those low latency use cases. We've seen this show up in a number of places where you've got really fast query engines that are trying to cache or use some other mechanism to improve the performance for the client side. But a lot of that really depends on your ability to know if the table has been updated behind the scenes and you're providing consistent results. So with that, I'm just going to say there's lots of ways to get involved with the community. Again, from the beginning, we've got the actual GitHub where you can file issues and contribute. Slack is a great place to communicate with the rest of the community. And the website has links to all of the calendars that we use for hosting these discussions. please join us and have a great day. I think we have like 3 main tracks. There's a lot of deep dives in these areas. I'm excited, and I hope you have a wonderful time. Thank you.